Welcome back, ladies and gentlemen. We are doing something a little different here. We had you guys do some stuff in class off of Agile Mind for student activity sheets 2 and 3. And we are back on Agile Mind for student activity sheet 4. And this is called Transformations of Linear Functions. Okay. I don't know if you guys have seen Frozen 2, but Olaf, I have a 3-year-old, so Frozen 1 and Frozen 2. It's like it just alternates what's played in our house. Sometimes we watch Frozen 2 multiple times, sometimes it's Frozen 1. But, anyways, in Frozen 2, Olaf talks a lot about transformations and that how he still doesn't fully understand what transformations are. Well, if Olaf was taking our class, he would understand by the time we were done today. So let's go ahead and take a look at this, guys. You're not going to remember the social studies game in class because we skipped that. But what they did, all these data points that are on this table here is the data from the game that they played. And with that, they came up with this red line, which is represented by the equation y equals 2x minus 30. Okay. So they want to know, kind of backing off the data now, they want to know if we look at this graph at the equation y equals 2x minus 30, that would be this line right here. And they want to know how it compares to the equation y equals x, which would be this line here. Okay, so if I look at these guys, I know that both of them have slope, and they both have a y-intercept, right? I know that both of them have different slopes and y-intercepts. Okay, so let's talk about it. The trend line that they came up with, that's the blue. If you want to write that down, this is the trend line that they came up with in a previous page. Okay, the trend line has an intercept of negative 30, while y equals x has an intercept of 0. They both have positive slopes, up 1 over 1, up 1 over 1, up 1 over 1. The blue line, the trend line, has a slope of 2. Okay, the trend line is a lot steeper. It's more uphill than my equation of y equals x. Okay. So now the next thing that I want to go through, guys, when we're going to be talking a lot about this equation of y equals x today. What is that equation? That is what we call the parent function. Guys, circle it, star it, highlight it. You are going to hear about parent function for the remainder of your mathematical career in high school. It's going to come back again later this year in Algebra 1. It's going to come back in Algebra 2 multiple times in Algebra 2. It's going to come back in geometry. It's not going away, guys. Parent function. I'm going to actually use Mr. Case's way of talking about parent function. If you guys have ever seen the movie Independence Day, I haven't seen it in like a good 20 some years. So maybe I need to watch it again this upcoming 4th of July when it marathons almost all day long. Okay. But anyways, in this movie, they've got this alien ship. Okay. And she's like what they call the mothership. And what she does is she sends all these other alien ships down to Earth to do her things. Okay. So I want you to think of the parent function as like the mothership of our different functions. And guys, what we mean by functions are just another way of saying equations. So instead of parent function, we can always call it the mother function. Okay, and with this, guys, this is just like our parents. We get certain traits from our parents. If my parents have a darker skin tone, I'm going to have a darker skin tone. Or maybe one of my parents has a darker skin tone and one of my parents has a lighter skin tone. I'm going to have a mix of something in between. Okay, that's kind of how the parent function works. Is the parent function is what we get everything from. okay? The parent function is y equals x, and this is just for a linear function, just for lines, okay? We have different ones for other shapes. But our parent traits, the parent trait here is going to be the equation y equals x. We can also write this as f of x equals x. Remember we talked about functions. F of x is a fancy way of saying y. Okay, so this is your parent function equation. This is where all of our other equations stem from. Okay, and what they want to know is how do other linear functions compare to the parent function? So how do all of our other equations compare back to this equation? Okay, well, what it is that all other lines, they start here and then they have variations and they transform. Okay, so something I want to talk about, we've talked about rate of change. Well, guys, a big thing with rate of change, the big thing to remember, it's slope. It is slope. So how does the rate of change of linear functions affect the graph of a function? Well, as a reminder, the bigger, larger the rate is, the steeper the graph is, meaning taller. Ignore that. Smaller equals flatter. Negative turns it downhill. Okay, just a couple of reminders there. Okay, let's go ahead and turn that page. Okay, so now let's talk about how positive and negative values for slope affect the graph of a line. Again, this is a reminder, guys. A positive slope, okay, positive slope rises from left to right. And again, as a reminder, in case you still haven't gotten this yet, that means it looks something like this. Okay, and then with that, our negative slopes, they go the other way. They kind of look downhill. They fall from left to right. Okay, negative, nice negative. Okay, it goes downhill. Okay, and this should all be review here. So now they want to know, how does the graph y equals 2x minus 30 compare to the steepness of its parent graph, y equals x? Okay, and we can look at these over here. Okay, here's our parent line, our parent function, and then here is the other equation. Okay, and what we notice is, I know my parent function has a slope of 1. That's like y equals 1x. Okay, it has a slope of 1. Whereas the equation that got transformed here, it has a slope of 2. Both are positive, but the second line, my green line, is a lot steeper than the parent function. Okay, something else. Let's go back and look at these graphs. They want to know, how is the y-intercept different? Okay, well, the y-intercept is what moves our graph up or down. Remember, we go starting on B, we about to have fun, graph, okay? It's our movement up or down. So when I look at the parent function has a y-intercept of 0. Okay, this is our parent function. In this function, it has a y-intercept of negative 30. It's down here. So that means that they shifted the graph down 30 units. Okay, so let's go and compare the y-intercept. Okay, the y-intercept, it is negative. It is down 30 units. And then again, the slope, it rises at a steeper, faster rate. Okay, so what we're going to do here, let's see if I can, Agile Minds wants to load here for us. Okay, so what we have, guys, I have 3 different graphs here. And what we want to know is what transformations does it make from the parent function? So they give me the equation 3x plus 1 for this first question. So I'm going to choose this equation. Remember, they want to know what we have to do to the graph, okay? So the first thing they wanted us to do is drag the red point to adjust the slope of the line. Well, this line is up 1 over 1. Well, we need to make it go up 3 over 1. So I'm going to move it 2 more units up. It was already 1 unit up. And we can test this, guys. You can take that back down to 0 and go up 1, 2, 3 over 1. Okay. Now it has an intercept of plus 1. So I'm going to bring my graph up 1. Let's check it. Yay! We did it. Okay. So let's talk about what we did. Okay, I shifted the graph up 1 unit, and then I increased the slope to up 3 over 1 instead of up 1 over 1. Okay. So now let's go to this next equation. This would be 1/2 x minus 3. First thing I'm going to do, instead of up 1 over 1, I'm going to go up 1 over 2. And then my y-intercept is -3. 1, 2, 3. And let's check it. Yay! What did we do? I shifted down 3 units from my y-intercept. And then my slope was up 1 over 2. Okay, now my last one. Let's switch to my last one here. Okay. I'm going to start with my intercept. It shifts down 1, 2 units. My slope is now -3 over 1. Okay, so something I'm going to have to do, guys, we have to reflect this across the x-axis. Okay, so I reflected. That's what that negative does. And then instead of up 1 over 1, it's going to go up 1, 2, 3 over 1. Check my graph. Okay. So there's a couple of things that we can say. Shift up 2 units, did that. Reflect it, so we made it go this way. And then we went down 1, 2, 3 units and over 1 unit. Okay, so now they give us these 2 equations here. 1 and 2. I want to know, in terms of transformations, how are they related to one another? Okay. Well, the first thing that I notice here, guys, is that it's kind of out of slope-intercept form. Okay. But regardless, they still provide us with the y-intercept and the slope. Remember, our slope is going to be the number in front of the x. Oh, in this first equation, my slope is 0.07. In my second equation, my slope is 0.07. Okay, so the first thing I notice, guys, the slopes are the exact same. The slopes are the same, which means that they are parallel lines. Okay, they have the same slope, but different y-intercepts. In this equation, 16 is my y-intercept. In this equation, 26.1 is my y-intercept. Okay, they have the same slopes and different y-intercepts, which means that these lines are parallel. Okay, in terms of the shifts that are happening, I'm going to start with the bigger number. We could go either way on this. I said that we shifted the graph of 26.1 plus 0.07x down 10.1 units. We took this graph right here and we shifted it down. That's all we did. It's the same exact line. It's just down 10.1 units. Okay. And then question 13. To summarize, what characteristics of our parent function, our mother function, y equals x, do we have to change to get any other linear graph? And that's basic, the slope and the y-intercept. Okay, those are the two things that we change. All right, let's go on to the next page, which is matching. So here, mine's gonna look different, guys. We need to match these graphs here with, sorry, not those graphs. We're gonna match these graphs here with the graphs, the words that are up here. So first thing I'm gonna do is I'm gonna make this a little bit smaller. Well, okay, the one thing you guys are gonna notice, there's 6 word problems here and there's only 5 graphs. That means one of these word sets does not match anything else, okay? So the first thing I did on my paper was I noted, okay, what is going on with this graph? I noticed that it was shifted down 1 unit and had a slope of 2/3. So what I did is I came to my words here. Which one of these talks about shifting something down 1 unit? Well, this one right here, the graph of f of x equals x with a rate of change of 2/3 and shifted down 1 unit. So they're saying the parent function now has a rate of change of up to over 3 and it's shifted down 1 unit. So I'm going to drag that right there. Okay, my second graph, which matches this one, I made note that the y-intercept on it is 2, meaning it was shifted up 2 units. And my slope is 1/1. So nothing changed with my parent function except they shifted it up 2 units. Well, right here, graph of f of x, the slope is 1, shifted up 2 units. Okay. And then my next one here, my intercept is +2, okay? And my slope is 3, okay? So my intercept, the graph was shifted up 2 units and has a rate of change of 3. So I used that one, I used that one. This one says shifted up 2 units, but it says reflected. Well, we didn't reflect it. Here it says it was shifted up 2 units and a rate of change of 3. Okay. Now we have these 2 problems down here. First thing I noticed, guys, it's reflected. This is a negative slope here. Boom, 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 boom. It is reflected. There is only one set of words here that talk about, oh, never mind. There's 2 sets of words. They've got 2 sets here that talk about reflection. So let's look more at this. It is shifted up 2 units. So this one right here, this -5 means that it would be shifted down 5 units. And that's not the case. Right here, parent function shifted up 2 units. And then lastly, guys, this one has an intercept of -6. It is shifted down 6 units. Guys, there is only one thing here that talks about that. And I also know that the graph is now up 1/2/3. It's 2/3 as steep. So I'm going to drag that top one down. Maybe. Whoops. Drag that down. And we can zoom in for you guys to see this. Okay. And then lastly, we're going to go through some of these transformations. And I'm going to try to make these as clear as possible for you guys. What's happening with these transformations? We have some rules. Okay. So as a reminder, we have the parent function f of x equals x. This is also like saying y equals x. So they want to know, well, what if we take the y value and subtract 2 of it? Okay. That's like saying y minus 2. Okay. So with this, guys, they're saying if f of x equals this value right here. Sorry. If f of x equals x, then what they're saying is if we take f of x and subtract 2, we're going to take our x and subtract 2. It's like, remember with equations, guys, balancing what we do on one side, we must do to the other. That's the same thing. And all that means is that we are going to shift this 2 units down. Okay? That means that we're going to take the graph and we're going to shift it from the center here 2 units down. That's it. Okay? And as something to remind, if f of x is plus or minus a number, that means we're either going to shift it up or down. Then our next thing we have, if they say take f of x minus 2, see the difference between the two of these? Here, my minus 2 is outside the parentheses. Here, it's inside. What they're saying is if f of x equals x, then f of x minus 2 equals x minus 2. I know, guys, this is confusing. This is like a horizontal shift. I'll shift left or right. Okay? And all this does is this would shift the graph 2 units to the right. Meaning if it says f of x minus a number, that means we shift it to the right. F of x plus a number shifts it to the left. Again, note the difference between inside parentheses and outside the parentheses. Okay, so this one, it shifts it from here to here. Okay. Go to question 16. Okay, question 16. These next two are pretty much the same for right now. It'll change when we get to other sections, but right now it's the same. Here we're going to take f of x and multiply it by 3. So if f of x equals x, if we multiply this by 3, that means we're going to multiply our x by 3. This is what we call a vertical dilation, okay? The slope is going to be 3 times as steep, okay? If you want to make a note here that we multiply our slope, it multiplies the slope, okay? Again, a number times the f of x means that we are going to stretch up or push down the slope. Okay. And then lastly, for right now, if f of x equals just x, ignore that. Wow. If f of x equals x, then f of 3x equals 3 times the x, okay? And this is the same thing as above for now, okay? And with that, guys, you have reinforced problems to do with your teachers. Bye.